So we've looked at using the sine rule to work out a missing side in our previous video. In this video we're going to use the sine rule for working out a missing angle. So in triangle ABC, the ratio of side A over sine of the angle of A is equal to the ratio of side B over sine of the angle of B equals C over the sine of the angle of C. Now, to work out a missing angle, what we're going to do is we're going to invert this sine rule. So instead of having A over the sine of A, we're going to write it down as the sine of the angle of A over A equals the sine of the angle of B over B equals sine of the angle of C over C. So our ratios are still in the same proportions. So in this example, we want to calculate the size of angle X in the triangle shown in the diagram. So we've got triangle JKL. And angle X is at angle L in this diagram. So our sine rule for angles is the sine of angle A over side A equals the sine of angle B over side B. So going back to our diagram, we've got angle X, which is opposite the 15.8 meters. So we're going to mark our angle X degrees as A, and we've got our side 15.8 meters as side A. And then we've got angle of 74 degrees opposite 18.2 meters, and so our side is going to be B and our angle 74 degrees is going to be angle B, and we're going to substitute that in. So the sine of X degrees is over 15.8, and that's going to equal the sine of 74 degrees over 18.2. And we're going to isolate sine X to start off with. So sine X is going to equal 15.8 multiplied by sine of 74 all over 18.2. And then to isolate the X degrees, we want to use our arc sine button or our shift sign on our calculator in order to work out X degrees. So that's going to equal arc sine or sine to the -1 of 15.8 sine 74 all over 18.2. And if you calculate that separately, use your answer button so that it's accurate. Don't round too early. And 57.38 degrees is going to round to 57.4 degrees to 1 decimal place. Now in the final example, we want to find the possible sizes of B and A in a triangle where C equals 40 degrees, B equals 7 centimeters, and C equals 5 centimeters. And you can see in the sketch that it shows two possible triangles. And that's because the question is asking for the sizes, plural, of B and A. So if we start off working out angle B in our acute scalene triangle, we're going to sketch that separately. So our top vertex is B. The adjacent side to that is 5 centimeters, opposite B is 7 centimeters, and our bottom right vertex is 40 degrees. And our sine rule states for angles, sine of angle A over A equals sine of angle B over B. Now, if we go back to our diagram, we're going to work out our pairs of sides. So we've got angle B over 7, and we've got the 5 centimeters opposite our angle of 40 degrees. So the sine of B over 7 is going to equal the sine of 40 degrees over 5. And that means that the sine of angle B is going to equal 7 times sine of 40 degrees all over 5. And if we put that into our calculator, B equals the arc sine of 7 sine 40 all over 5. And this gives us an angle of B of 64.14, and that rounds to 64.1 degrees to 1 decimal place. Now we want angle A as well, and so to work out angle A, we're going to have to do 180 take away the sum of 40 plus 64.1, and that's going to give us an angle of A, when B is 64.1, A is going to be 75.9 degrees. Now our other triangle was when the angle at B was an obtuse angle. Now we know that the obtuse angle for any acute angle is going to be 180 take away that angle. So B is going to be 180 take away the 64.1 degrees, giving us an obtuse angle at B of 115.9 degrees. And then we're going to work out A by doing 180 take away the sum of 115.9 plus 40 degrees, our angle at C, giving us an angle of A of 24.1 degrees. So to write out and explicitly state the final answer, A equals 24.1 degrees, or it equals 75.9 degrees, and B equals 115.9 degrees when A is 24.1, or 64.1 degrees when A is 75.9.